So good afternoon. I am Anto Budiarjo. This is Monday Live. This is what we do every Monday afternoon at 3 to figure out what the future is in smart buildings. Our profiles are all listed on mondaylive.org, just in case you wonder who we are. Just to note also that views expressed here are personal, not of any company or organization. Please do post comments and chat on the Zoom. We really want to make this as interactive as possible. If you want to see any of the material presented on this slide deck, it is available on mondaylive.org. So head over there. This being October, Cybersecurity Awareness Month, and the Monday Live theme for this month is cybersecurity. So we're going to be talking about that today, our normal agenda and our normal chit chat, and then we're going to be talking about how to secure dynamic systems, or some sort of approaches and what's different about that. And we do have a guest that will join us, John Gita from Archivist. That's how you pronounce that, RKVST. Took me a while to figure that out. But before that, Ken is not with us, but Mark's going to do his best impersonation of Ken.
Well, that's kind of pretty hard because we all know Ken's a unique person unto himself. So obviously the recent switch by Ken in Automated Buildings to, instead of a monthly type publication, it's turned into live as soon as folks who want to and can contribute post some articles on there. So Ken's gone out on a limb and started talking about creating a metaverse persona. So suggest you read it, because I'm still trying to scratch my head. Do I even want a metaverse persona? I think I got enough personas as it is. I wrote an article on there really more about the importance of value in our industry, and it's entitled "Nobody Wants a Quarter-Inch Drill, They Want a Quarter-Inch Hole," and just talks about how our industry, how we need to be continually talking about the value of our products and solutions and offerings and what we do, not just the features, functions, speeds, and feeds of stuff. And then another article here on how Echelon today is changing a little bit, their recent announcement with Enocean and whatnot. So some good reading materials. Let's go on to the next.
I was wondering, Tracy, if you can speak to that, what's going on there briefly.
Sure. So there's been another acquisition. It's a little convoluted in that the part of the organization that Renesys had purchased that does the chip manufacturing, chips and transceivers, is going to stay with Renesys. But the rest of the group, the people, the technology, and the products, smart servers, and kind of the board level products and software products, was acquired by Enocean. Work has started here to see what the world looks like with kind of a tightly coupled combination of Enocean technology, which is the energy harvesting wireless, for those who might not know, and LawnWorks and the associated products with that. So that is done. People are starting to settle into their new roles. I've started conversations with the Enocean Alliance to see how the Lawnmark Association and the Enocean Alliance might even work together going forward. So a bit of a strategic purchase from an Enocean's viewpoint. They interestingly had come to sort of the same conclusion that the Lawnmark Association had come to, which is our world is going to have to be protocol inclusive, is the term I came up with, where there's not just one protocol. We're going to be mixing and matching for the foreseeable future. So all of that seems to be moving forward nicely. I'm kind of excited to see how this is all going to come out. So.
Was there a value put on it, Tracy? You know, the acquisition?
No, unannounced. Enocean is a privately held company, so
No.
yeah.
I'd just be interested because it kind of
I would
would
be
give an idea of the
too.
value.
I hope to learn before it's all said and done, actually. Yeah.
So protocol inclusive, that's definitely sounds like a euphemism.
Yep.
Let us move on, shall we, on that? Back to you, Mark.
You know, it's interesting. I found this article, and there's two links here. One is to the article, the other is to the content that they mention about empty buildings consume more energy than you think. Obviously, for us, we all know this, and we started talking about this months and months and months ago once we were in the COVID mode of operations of buildings where there weren't people in the buildings and the systems were going full bore. But there's some scientific stuff that I think really supports this. And so the reason why I wanted to put it up there, one was the scientific support of it. And then two, that really gives the proof that being able to control and use energy in our buildings with static schedules is really important. And it's, you know, the wave of the future, so to speak, even though, again, everybody on this call, including attendees and panelists, we know this, but, you know, sometimes it's hard to get this across to folks who we are trying to do business with. So a really good article. You want to go to the next one, Anto? And just a reminder, we've got one more session left in Haystack Connect's virtual webinar series. It's coming up Wednesday, November 9th from 11 to 12:30. And this will wrap up our webinar series for this year. As you can see, we're going to be covering Haystack in practice, some review of the labs and the working groups that is taking place, VRF working group update as well. And we're also going to hear from Corey from DataQuip and how they've been utilizing Project Haystack and some of the things that they are doing. So if you haven't registered, there's a link you can register. Again, it's all free. And if you have registered, you should be getting some emails, etc. But hopefully you can attend. I think all the feedback we've heard thus far from the previous sessions has all been really good. And hope you can join us. Back to you, Anto.
By the way,
Thank you,
Mark, looks pretty short and sweet. I mean, that's an easy, you could jump in there and learn a lot pretty easy in like an hour and a half.
Yeah, thank you. That's one of the reasons why we kept it this way instead of doing it 3, 4, 5 hours. We're all busy, and let's do the short burst and then break them up where if you don't want to attend all the content that we were able to do, just attend what you want. And so I think this is a new way to do things, the virtual webinar series. However, that said, be on the lookout. We'll announce shortly. We are going back to live in person in 2023. So stay tuned for more coming up in the near future.
Okay, thank you, Mark. Gina. Are you there, Gina?
I am here, yeah. So a little bit late past our cybersecurity month, but I just wanted to kind
We're
of
right
share.
in the middle of it.
Yeah, well, okay, so this might be a little bit old, dated information, and you guys might have something of more dated, or updated. But I found this. I was kind of trying to figure out, is anybody keeping, tabs on hacks or whatever within the OT world. And so this right here, it's like I said, it's a little bit dated in 2019. So these stats came from the first half of 2019, which is almost 4 in 10 computers used to control smart building automation were affected by malicious attacks. And it says 11% of these were from spyware. And then they said about 26% of these came from the web or the internet, with equal amounts, 10% coming from removable media and email links and attachments. So then the other thing was on December 21st, there was a German office building that lost contact with all hundreds of its BAS devices. So hackers gained entry into their system and it wiped all of their programming off all of their controllers. And it actually blocked out all the engineers. And they had to hire a firm to come in and kind of reverse engineer what the hackers had done to actually get access. And then they had to rewrite all of their programs. And so 3/4 of their devices were purged and locked down with their own digital security key. And on this particular slide, I have the hyperlinks to both of these, the information on this particular company, and then the stats that came in here. So I just thought I would share that. And I actually think 4 in 10 computers, that's pretty high for the first half. And it actually had, this had increased almost 6% from the year before for the prior year.
That
So,
seems very high. That seems very high to me.
Yeah, I think, like I said, I tried to find a little bit more updated information, but I couldn't. But I did think that the article on the German office building, and it didn't give a lot of detail, but it did give you kind of the high level of what happened. It didn't say how it happened, what had happened, and then how they were able to get back. And they were only able to actually get back in because the company they hired to look at what the hackers had done had left their program on a bricked gateway. And so they were able to reverse engineer that and get access to their network.
Okay. Right. Thank you, Gina. I came across 2 things. One is Larry Ellison, who's the CEO of Oracle, came up with this term, Internet of Clouds. And what he was actually speaking about, and there's a quote that's actually from one of his executive vice presidents, is really sort of something that we've talked about on Monday Live, on and off, which are these sort of the growth of these huge cloud providers that some argue does not provide a sort of a very flexible way of actually making these cloud providers work with each other. They're sort of almost sort of a walled garden sort of concept, which is what he's talking about. So it's just interesting that he picked up on this as being an issue because he reckons it's a big problem, and he's obviously Oracle are going about it a certain way. So I thought that was interesting. And the second one, a little bit very, very different, which is some new data about the number of babies born in the US in the last couple of years has gone up. So there's a small baby boom. Does this mean we're going to have another boomer generation? I don't know. But I just thought that in terms of the impact of the pandemic, we talked about how it's impacting buildings, but this is just another sort of impact of that.
Maybe it'll be the boomerang group instead of just the boomer group.
Oh, boomer 2.0.
Yep.
Hey, look, we need more babies. This is good. I personally just hired a woman. She started this month, who just had a baby 4 weeks ago, and another one a year and 4 weeks ago. And here she is making calls, getting after it. You can hear the kid in the background. I friggin' love it.
Good. Any other thoughts? Or
Just one, as we're talking about, it's a bit of a downer, really, I suppose. But at the Smart Building Show, I was talking to Jim McHale, the guy who actually runs Memori, who do all the research projects and stuff. And he actually said he cannot believe it. It's the first time he's ever had a report where nobody's bought it. And guess what it's about? You can guess it. So cybersecurity.
Wow.
It's just I cannot believe this. He said, "Yep." He said, "I've actually sold 0." He said, "I've never had a report ever where I haven't actually sold some." But
Wow.
shows we've still got quite a way to go in terms of people being educated and perhaps wanting to actually get more information about it.
Is it
That
that, Roger, as far as, yes, always, again, this is a subject that we can never stop talking about, but do you think that the people in our industry, for the most part, those who are interested in this and take it seriously are already doing something, are already doing their research and have plans and strategies, versus the ones that don't, just see ya, don't want to be ya, I'm done.
Well,
I don't care.
I guess you could say that about most things, Mark, one way or the other, but you'd have thought someone would have been interested in the management chain or somewhere. But
Yeah.
yeah, it's the first time he's ever had a report that's not, that sold 0. I mean, he may have done now a couple of weeks later, but he said very little interest.
That's super interesting.
Yeah, and they're a good company to get reports from. They do good search and reports.
Yeah, Toby just chimed in that they may just be a saturation. There's just too much. And
yeah,
Roger, it may be that that they're marketing to the wrong audience.
could
And
be.
the reason I say that is I'm on the cyber side of my world. Every, I'll call them enterprise account that I'm getting visibility to is is involving cyber in multiple ways.
Right.
And but that being said, in each and every case, IT has a seat at the table. So if you're not, if memory is not reaching out to the IT folks in addition to their traditional facilities audience,
Yeah,
I think that's going to hurt them.
could be.
Yep.
Could be. Yeah.
okay, so there's nothing else. Let's move on to cybersecurity, because we care about it. And this is what we've gone through this month. We talked about managing, and then we talked about different perspectives from outside the industry. We talked about great presentation last week from Jason on Zero Trust, and we're going to be talking about securing dynamic systems today and talk about BACnet next week. So to frame this conversation, I'm going to bring in our guest, John Geeter, to join us on the panel here. John and I and a number of other people wrote this paper within the Digital Twin Consortium called Assuring Trustworthiness in Dynamic Systems. And some of the things that we'll be talking about will be sort of based on this, but really only to sort of expand our thinking about, we're talking about cybersecurity. It's not really just about security. Lucian, a couple of weeks back, talked about safety, and there are obviously the sort of other issues to do with trustworthiness, which is kind of the framing of that. So we're going to be, I'm going to make a couple of points with some slides, and then we'll have a discussion and have John chime in with his thoughts. So the first question is, what is dynamic? What do we mean by dynamic systems? And this little matrix came out of some work in the Digital Twin Consortium about a year ago. We were trying to sort of understand the difference between static and dynamic systems. And I thought it was very, very telling in terms of how it explains it. So it comes in sort of in a number of different sort of dimensions of what the systems are. So from a composition perspective, a static system is predefined, right? So there is some kind of specification in terms of what the system is. So clearly in sort of control and automation, or certainly control, is very much a static system because you have a specification. There's a lot of work going on about specification. That's exactly what that is. In dynamic systems, it's not necessarily predefined. You may not actually know what the composition of the whole system is. The second sort of attribute is completeness. With static system, you know what the end result is. You know it's deterministic in terms of what it is you're trying to do, and therefore there's an end date. And we think in sort of commissioning, and the handover is really the signal for that. And a dynamic system is not deterministic because it will continue to grow and change. And then it changes. There are differences in terms of who constructs it. Static systems are typically constructed by a single entity. There may be multiple entities working, with each other and sort of subcontracting and whatever, but there is a single entity that's responsible. Whereas in dynamic systems, that is not the case. When you have two systems starting to work with each other in a way, that is a dynamic system, and it just grows from there. The maintenance of it is different because the way you maintain a static system is, again, similar to how it's created, is controlled. Whereas the dynamic system, we think, is much more collaborative. And the last one should ring true to all of us here in terms of how the components of a static system are connected together. And with static systems, they're tightly integrated typically because they want, you know exactly what you want, and we know exactly what the functions of all of the components. Whereas in a dynamic system, you can't really do that. And that's why interoperation comes into play. That's why interoperability comes into play, because you really want all of the different components to be able to work with each other without any effort of integration. So this is kind of one way of thinking about that. So hope that's insightful. It was certainly to me. The other sort of thing that is this within this paper that John and I were co-authors is not to just think about security, but to think about trustworthiness. And we got a little bit of help because a couple of years ago, the Industrial IoT Consortium created a different paper on what they call trustworthiness framework, foundation for that. And they said, they basically, it's a long paper, and it sort of speaks to the fact that trustworthiness is really made up of 5 dimensions. It's made up of safety. You have to care about safety, resilience of the system, the reliability, the security, and the privacy. And all of those things combined really sort of makes up trustworthiness of a particular system. So this is, you'll actually see a lot of reference to this in the paper that John and I were involved with. And so the question is, how do you create a mechanism so that dynamic systems can understand the trustworthiness of all other entities, right? Because in a static system, you know that when you install a particular product, as long as that product conforms to certain standards, UL or whatever, you know that's going to be the same product as it will be in 10 years. But in a dynamic system, you don't really know what's going to come in and out. And so what we came up with is a concept that we call trust vectors. And trust vectors leverage the 5 dimensions of trustworthiness that I showed in the previous slide: security, privacy, safety, and reliability. And what it does is it basically says, it provides a score between 1 and 5. And what this column is saying is that system X, a particular system, needs these levels for it to operate. It needs for something else to be able to connect to it. It needs to have a security score of 4, privacy score of 2, et cetera, down this table. And when it has an opportunity of connecting to, let's say, 3 different systems in a building or in a particular context, they then provide scores of their abilities, of what they can do. So in this case, A is basically saying, as far as security, I can only do a 1, right? And it goes all the way down to the different areas. So with this, the whole sort of notion of this trust vector is you can do extremely easy and fast math to figure out that, and you can also see it here, that C is really the only one that you should be talking to, because you have no idea. I mean, B is really terrible, and A, depending on what you're trying to do, is actually middling, right? So this is the core of the mechanism. And I'll show you one other slide, which is it's quite complex, and I'm not going to explain it all because it's actually explained in the paper. You start to sort of be able to combine systems together and use this trustworthiness, the trust vector mechanism that I showed you in the previous slide, to enable the different systems to be able to exchange information with each other in terms of their respective trustworthiness, so they can decide whether to use the data, whether to communicate with that system, whether to use the data or not from that particular system. So that's kind of the mechanism. I'm not going to go into detail about this, but the paper is available to download now. It's actually officially going to be released tomorrow, but you guys have a sneak peek of it. I'll put the link on chat, but it's also on the deck here for people to refer to. So I'm going to stop here. I'm going to invite John to make some comments. He was obviously involved in the creation of this over the past year and a half, and introduce yourself and sort of put in your perspective of this paper and how it relates to all of the trustworthiness dimensions.
Yeah, thanks very much, Anto, and nice to see everybody. Thanks for spending another Monday night here. So yeah, I mean, my background is all in cybersecurity. I've been doing it since the 90s, working with big systems, all the fancy words that everybody associates with cyber, like encryption and hardware security modules and PKIs, things like that. But it was when I started working more seriously in the aerospace space that it turned out, the security of the internet, which dictates so much of the kind of products and services, the standards that we have for cybersecurity, that security of the internet is really bad as a model for the security of the Internet of Things. And specifically, the reason why is that typically the stuff that's neatly packaged up and easy to understand and easy to deploy for an enterprise is built on the idea that your stuff is a castle to be defended, and absolutely everybody else is an adversary to be kept out of the castle. And the crucial trade-offs then between kind of absolute perfect security and all of the helpful human features you need, like backups and password resets and all those compromises that you have to make it actually usable, they tend to concentrate power in a single place. You have like one company that is prime, if you think about kind of web servers in old SSL, or you have one department which is primary if you think about the sort of all-powerful system administrator who gets to reset your passwords and see all of the file shares and that kind of stuff. And that model's great if you have this big sort of imbalance in power and responsibility, but that model is terrible if you have what's essentially an equitable system. So as you grow out to Internet of Things, smart buildings, smart cities, my own personal experience before I started Archivist, my own personal experience was much more in aerospace. So it's things like airports, airlines, smart grids, that kind of stuff, big, heavy civil infrastructure. You've got lots and lots of companies all trying to play together, and they're all interested in security. But no one company is better, in quotes, than any other. No one company is more important or better positioned to decide how the security should go or what's acceptable. They're all trying to play together. They're trading operations, they're trading software, they're trading data a lot of the times. And you've got to make a decision ultimately as an operator, as a logo in many cases. You've got to make a decision. I've just received this signal from somebody else's box, and I'm going to decide to do something like open a valve or let a train go through a light or whatever it might be. I'm going to expose myself to insurance risk, or possibly worse, on the basis of something that somebody else's computer decided to tell me. And I need to know now, is that actually the computer I thought it was? Even if it is the computer I thought it was, is it properly maintained by the guys in the other department who I don't know and have no control over? Even if they claim it's properly maintained, what are their standards? What are their qualifications? Who do they hire? How good are they? Because until I can understand all of that, I can't really import any risk into my own organization from somebody else's. And unfortunately, that's entirely what digital transformation is. It's all about moving faster and importing value from other people's organizations. And so this difficult quandary that I spend most of my time doing, my whole company is based on, but also happily what this paper talks about, is getting to that next layer down. So no longer treating cybersecurity or data security or data provenance as a black and white issue to say, well, yes, I've got some magical cryptographic key, so it's good or not, but rather working with the idea that knowledge is power and that knowing more about the system you're dealing with enables the relying party, the people importing the risk, making some critical decision, having all that information available to them allows them to take control of their own risk, make an informed decision, and then move on and really take advantage of digital transformation in a way that I think we quite often find people are still rather nervous to do, because they're not sure they can flip that big switch and just let the computers run without having a human in the loop and doing those manual operations. So what the paper tries to do is to lay out a practical way of understanding this sort of subtle but really important shift in mindset from black and white, it's just secure or not, the padlock on the browser, to a slightly subjective idea of, move your dials up and down, work out what's important to you, and then assess the ground truth against your own principles. So it does that, and then it also looks to give a real practical way of implementing that, so that people don't have to worry about sort of scratching around, building it from scratch. That's never going to happen, right? You've got to find vendors, and there are vendors available, but the language of trust is very different to the language of security. And so what we also tried to do in the paper is make it easier to identify vendors and consultants who can actually help you to do this thing, and not just try to drag you back to the old world. So something something that I really liked about what Gina was showing, I mean, sure, they're slightly old statistics, but this stuff has been happening for thousands of years, so I don't think we should worry about stats that are 2 years old. The other thing which is very different about big systems and cyber physical type security to standard internet or enterprise security is the influence of the safety or the resilience or the reliability mindset. That's a big difference, and actually it's a very welcome difference. I really like safety nerds. Safety nerds are great because they know how the real world works, and they understand that it's not perfect, and they understand that you make trade-offs and priorities, but that leads you to building products and systems and protocols that actually let you prioritize on the stuff that's really genuinely important. And the flip side of that is then, so great, yes, we bring in other kinds of professionals, but also I'm also slightly skeptical of that 40% number. I suspect that it's not that they actually had malicious attacks executed on them, but that they contained vulnerable code or something of that nature. That I can believe. But nevertheless, it's an interesting and important point that the vast majority, and I'm sort of drawing on figures from the UK National Cybersecurity Centre that does biannual reports on these kinds of things, but I'm sure it's true in all sorts of places. The vast majority of problems that arise in industrial networks and corporate networks are not the result of a direct targeted attack from a motivated specific attacker. They are either an opportunistic attack as a result of just firing out a huge botnet or kind of port scanning and finding things or whatever, or they're the result of an accident where it's not so much that a piece of software was specifically bad, or it's not so much that an attacker was deliberately trying to blow something up, but rather that something which was fit for purpose for a relatively low risk use case, or that was tailored and calibrated and maintained for a specific kind of machine use case, accidentally found its way into the software stack or machine stack of, let's say, a medical context or a transport context where it hadn't been properly tested, it wasn't fit for purpose, and things just went wrong by accident. I think that's the other place where the paper really helps in terms of this kind of knowledge is power idea and getting the lay of the land and assessing the ground truth against your own principles, is to say, look, nothing is either insecure or secure in its own right. If you bring software down to its tiniest components, it all works, it all does something. And what you really need to do is say, well, security to me means that what I expect to happen 100% of the time happens 100% of the time. And I don't care how many bugs or vulnerabilities there are in a piece of software if it doesn't affect that measure. And that's how you stay on top of cybersecurity patching and resilience as well, is to say, well, I'm getting 100 alerts a day. I know software's buggy, but tell me which ones are relevant to me. Tell me which ones I need to fix this week, next month, and tell me which ones I can actually ignore safely, because I know with evidence that it's not going to affect my safety posture or my insurance posture or anything like that. So all of those things, which won't be news at all to a safety professional, but are sort of relatively new to the pure security world. All of those things are explained, I think, quite well laid out and analysed in the paper. So if any of that sounds like it would be useful to your businesses, I hope it is, because I worked on systems based on these principles in things like smart buildings access, and it seems to help. It lowers costs and it increases throughput, which is all you can hope to do in the end. Then yeah, the paper's probably something you should read.
Yeah, one of the use case, I'll throw it out to questions, but one of the use case that's discussed in the paper is the use case in the manufacturing environment. And it was actually going through sort of scenarios. What happens if there's an AGV, an automated forklift, basically, automatic vehicle. What happens if that encounters the puddle in the on the factory floor, thus causing its brakes to be less effective? Right? What do? You stop the whole factory? No, you don't. Right? You know exactly what the parameters are, and you can. The idea there is you can then adjust everything else accordingly, so to slow the AGV down or something like that. But it's actually quite interesting, and that came in from the one of the other co-authors, Detlef Richter. Unfortunately, I invited him, but he's in Tokyo, so it's 4 o'clock in the morning. He works for a company called TÜV Süd, and they're basically kind of equivalent to what UL does in the US. TÜV Süd does similar sort of activities in Germany. So to John's point, those are kind of safety people that just think about safety all the time. So with that, throw it out to comments or questions.
So Anto, who is the arbiter of the 5 levels of trust vectorness?
The way it's actually constructed, and it goes into some detail in the paper, but not in ultimate detail, because at this point it's a concept of an idea, is that the entity, so you have an entity requiring trust, and then you have the entity providing trust, right? That basically says, I'm a trust level 4, right? So the question is, well, your question is, how can you trust that I'm actually level 4?
Correct.
Right, that's the point. And at that point, I'm going to hand over to John, because this is all to do with attestation and proof that you can actually do separately from the actual score itself. The score itself is just, let me in, I'm a 4. If you don't trust me, go and look somewhere else. John, do you want to?
So just a quick clarification. Doesn't that depend on the problem domain to some extent?
Yes.
Okay, I'll shut up now. Thanks.
No, absolutely, because a 4 in nuclear is different to a 4 in buying shoes or something.
Yeah, so I mean, there are two different answers to this. So there's a kind of tomorrow answer, which is, I'm sure we'll work it out, right? Although, trust scoring has been a topic for a very long time. I worked on this 10 years ago in the TCG, and I remember Pebbles was released. Gosh, yes, probably 8 or 9 years ago, and so we've gone through a whole cycle of product sets that have been conceived, released, and died on this topic in between those two times. So long term, this will have to evolve. The short term answer, which is still reasonably helpful, is that you have to think about these. All of these sort of concepts are an abstraction. So you can't say it's good or not. You have to say it is able to present how good it is. And what the one model of the scoring, which again is all documented, and there are additional supporting documents as well. One version of the model is to apply maturity levels to what people have, and there are a bunch of models. SMM has been around for quite a while, for example, which doesn't say very specifically, I'm a level 5 trusted, meaning you can trust me because I'm perfect. What it means is that you're able to present a level of operations and evidence behind that to a very high standard. That standard is documented, which says things like, yes, I review my security stance every week and I'm able to provide my reports to you. Yes, I employ somebody full-time who works on business quality and business resilience and has a 24-hour phone number and all that kind of thing. So what we do instead is have a bunch of topics which would be very familiar if you've ever worked in an ISO type environment, either 27000 or 26262 kind of spot. The kind of things that you have to do is not say exactly what you do, but rather say we have a process and everybody knows where to find it and it's followed. And that's the current state of the art is that. And then behind that, when you connect, you can request the documents, you make your own choice, but at least it's still only a one-off and not an every time human involvement.
But there isn't a third party certification authority, if you will.
Not a necessary one. So one thing I don't know if Anto chose that example on purpose. I happen to have a bunch of work in the nuclear space, and basically every operation, maybe pulling this back a bit, we like to think of all of these things as supply chains, right? No matter what you're doing, whether it's kind of inside company departments or whether it's multiple companies working together, the movement of data and the interaction between elements is essentially a supply chain. You're providing data inputs, somebody takes that on, they then make product, which might be a movement of an ATV, or it might be the opening of a spigot, or it might be the closure of a building. But that's kind of how these things flow. And what you're looking for is proof that the thing has properly been delivered from where you expected. It's been responsibly taken control of by the other side, and that you've got a coherent view of everything from each end of what you were looking at. And so when you've got that system in place in our nuclear use cases, you've got movement of things like actual physical containers. You have bags full of radioactive rubble moving about. And additionally to that, you need to check that the people signing off that, yes, I sent this thing and yes, I've taken control of this thing, that they are qualified to know what they're dealing with. And in that use case, the qualification is absolutely third-party certified, but it's not a necessary part of the kind of transactional or technical model. It's just a thing saying, I'm presenting my credentials, and it's entirely up to you what you do with those or whether you trust them or not. And that's actually, it might sound like it's a missing feature, but it actually makes it extremely versatile, because the credentials for an automated internet home router are a very different kind of format to the credentials for a professional qualification. And we abstract that away and just put it into the secondary decision loop.
The other thing that this sort of scheme enables you to do is to negotiate. right? And my example of the floor is wet, right? And that information may come from a CCTV camera that has AI to detect that, right? So it can then make the AGV aware that there's wet floor, right? So in a way, that's a negotiation that can happen with things. The scores can change up and down because, you know, half an hour, 30 minutes later, the floor will be dry. So, you know, everything can actually go back. So there's the dynamic. It's not just the dynamic of the systems and the assets moving around, but it's also the dynamic of the interaction to establish trust.
So John, a couple comments. I'm Steve Fay. So what Jim was asking, referring to in terms of some sort of formal certification, I know UL was doing some things a number of years ago. I'm assuming they're still doing it.
Mhm.
That would certainly, to have an organization like that get behind it as an option, right? It wouldn't have to, but I would think they would be interested in something like this where they could rate organizations and their products and services to this standard. Because, you know, let's face it, well, really it's about my second point, which is that cybersecurity is a secondary issue at best for most decisions around whether you're going to buy a building automation system or a lighting control system or a video surveillance system. Okay, so the customers evaluating their primary decision making on the feature set of the functionality of the system provider, right?
Yeah.
And so when that chart that Anto put up before, when you could just read across and say, well, you know, this guy meets all the things, fine. However, if they don't provide the functionality that I wanted to buy in the first place for how I want my video to work or I want my building automation to work, there's got to be some kind of an answer in the industry where whether it's a third party or third parties that can essentially fill the gap between what that organization is able to offer in terms of security and what maybe the buyer thinks they ultimately want to have.
Yeah.
So have you thought through that aspect of how you can take a sub-performing system from a security standpoint and make it still perform at the level that you feel organizationally you need?
Absolutely. I mean, that actually, so strong cybersecurity in the traditional sense, in the place I was working before, faced exactly that problem. Because the easy way of doing IoT security is to throw a TLS certificate on the box. You buy some kind of embedded SSL, and then you connect it to some CNC cloud, which does the authentication. And if absolutely everything is on that same system and have access to those same certificates and everything else, great. Otherwise, they just can't talk to each other. And this is a big problem when you're trying to build things like surveillance systems, where the door entry system and the CCTV and the fire and theft systems all need to communicate with each other and share the kind of data that Anto was talking about. So yes, absolutely, this is kind of the origin problem. And also, it would be great if we had Tooth Suit here, because Tooth Suit are basically the European UL to all intents and purposes. That's why they're interested in this, because they also want to be able to certify a dynamic system. You don't want to have a hermetic factory floor which is never allowed to change and never allowed to update its operating conditions. You want to continuously verify this thing and say, yes, it's still fine, it's still operating well, you know, this is great. So the UL connection, the Tooth Suit connection, I'm sure is still very alive there. So yes, very much that quandary is considered, that you can't expect everything that is bought to have the same security widget 5 or 6 layers deep in its design. And so what the negotiation, as you know, the PADI platform presents a good model for this. There are other ways to do it too, obviously, but what we view there is that actually, yes, you can negotiate, you can ask multiple sources, you can ask multiple questions and satisfy yourself that the answers you get back are ones that you wanted, which could be, I go and directly connect two devices together because they happen to be able to speak. It could be that you ask two separate questions, and if the answers are consistent, you're happy. So you don't need any integration at all. And so on. So again, it's kind of abstracted a little bit, but the ultimate goal has to be to not have a necessary single central certification authority that makes all these things play nice together, because that necessarily draws you back down the road of having to know in the factory at design time exactly what it's going to do, who it's going to talk to, and what it's going to say. And security is not just about having one identity or having a confidential pipe to talk over. It's also about reliability. It's also about availability and actually not going down. It's about having long-term immutability of data if you relied on it and need it back in a forensic report or an audit. So all of those things say actually the old model of a single central cert store doesn't really work if you want to have dynamic systems, and the paper therefore gets rid of them and says you can have one if you like, but it's only one of several models of trusting data and identities that you see.
And the other part of it is the composability of it, because we're talking about the trustworthiness of the trustworthiness information between systems. But it is assumed, and that's why on the last slide I was showing that this complex thing, which is actually explained in the paper, actually speaks to that, because the trust lines, the trust connections is just about trust. And there will be other relationships, other connections between systems that are more specific to capabilities, functional capabilities, right? As to whether I can turn on a light or do something that's necessary. So what we're doing is really separating the trust to be a sort of a dimension of information between systems. And then the assumption is that there are other information that is related to functionality, but it can also be other information related to commercial aspects, who pays who, for example, or anything else. So that's kind of the model that we're using here, is everything's all composable.
Yeah, or where it is.
Yeah.
The other commercial thing, do I trust it? Well, I may trust things from any geography for certain use cases, but only from the US or mainland Europe for others. Yeah.
Help me a little bit here, guys, in the, is it kind of what you're talking about here, is it that it should be inherent in the products that you're using, any product, or should it be something that is marketing? Clearly, as much time and effort on provide those secure individual systems they had, you'll be starting. So is it something that should be, as I say, within the product, or just something that's looking after the system?
We didn't quite hear everything you said, Roger, but I think I've got the gist of it. So Anto said an interesting word earlier, which is attestations. And this is a really, really, really important thing to understand about all of these things. And real security actually has always been this way. People try to convince you that an inherent widget will make things, beautifully indestructible, but it's never actually been true. So what attestations allow you to do, as the meaning of the word says, you get to make witness statements. So yes, in some cases, talking directly to the device or to the unit or to some service provider might be the best way to interrogate it and ascertain trust. But in many other cases, it may be that actually talking to somebody else and getting their take on it, getting some kind of reputation, or taking their observational scores, or taking their third-party ratings, is actually a better way to work out what you need to do. So again, it's very flexible. Strictly speaking, the technical model is all attestations. So it's all qualified people making observations about something else. But of course, the beauty of that model is that it's very easy to extend that to have a device or a system talk about itself. Whereas the other way around, with these kind of hard connected systems or certificate-based systems, it's a lot harder to turn it over and start from that and go the other way. So so no, the majority of things actually are third-party qualified witness statements and attestations. And like with Anto's use case, if the cameras say that the floor is wet and the traction control in the vehicles say the floor is wet, and somebody enters a manual report to say that the floor is wet, then you're able to believe that the floor is wet, even if the moisture sensors in the floor itself haven't noticed. And that's super important, not for kind of cybersecurity in the anti-hacker sense, but cybersecurity in the mistakes happen and we've got to keep safe kind of sense.
Did I get to your question,
Yeah.
Roger?
Yeah.
Other
So
thoughts from the
this is
group?
Mark P. Here's a question or thought. Is this trust? What is trust? In other words, our industry, for the most part, we're known for coming up with names, smart building, this, whatever it is. And yet we get 25 of us in a room and say, what is a smart building? As an example, we get 50 different answers. Trust, in other words, in the paper, and again, obviously, we haven't had a chance to take a look at it. In your terms, do you define what trust is in this environment that you just described?
We actually didn't. We actually used the IIC's definition of trust, which is those
All right, but there's a
five.
definition. There is a definition.
Yes. Oh,
Okay.
it's a long paper that defines that actually goes into a lot more detail that I get
Okay.
to.
Yeah, nobody agrees, Mark. Honestly, you could have 25 people in a
Oh,
room.
we know.
Yeah.
We know.
But yes, there is a concrete and long definition of trustworthiness, being extremely specific. That's what we do. And the thing that I really like about that, again, I guess I just enjoy thinking in abstractions, but the thing that makes it possible to define trust in that basis is that for me, it's simply, trust is simply that something does what you expect. Yeah, you can have something that's malicious, but if it's predictably malicious, you can still trust it. You still know what it's going to do, and you can deal with it effectively. And those 5 dimensions that Anto showed the slide on, and the way that they work together to provide your unique set of predictableness, the things that you care about, it is the best I've seen in 20 plus years of working in this space. So it's not perfect by any means, but it does allow people to make pretty decent judgments if you take all of those 5 dimensions together.
Yeah. And it also allows it to be adjusted for different domains.
Yeah.
Right, because that's important, because different domains have different, it's one of the reasons why people give different answers is because they're actually coming at it from very different perspectives typically.
Yeah, and we see that between the convergence of OT and IT. We've been seeing that for years.
Right, and what this approach says is that that's okay. Right,
Yeah.
it doesn't say you've all got to conform to X, because we're not going to do that as human beings. So we're coming up to a wrap. Somebody want to do a 30-second wrap? Tracy? No.
I think there are more qualified cybersecurity people than me to do a good wrap on this. Maybe Steve or.
Go on, Steve, go for it.
Jeez. So I guess what I find interesting about all this is that the challenge for securing these systems is inherently complicated, and coming up with a more flexible solution is needed in order to address the inconsistencies that are out there. So like you were pointing out, John, if you think you can just centralize things in a particular way, and therefore you've solved the problem, you really haven't. There's just too many other variables that come into play. And so as an industry, if we're going to, as we mature in this learning curve of how to secure our systems, we're going to have flexibility. And that means that we've got to have some sort of, I'll call it a framework in which suppliers, both from a manufacturer standpoint and from a service provider's perspective, are able to work together effectively to solve this problem.
Yeah, perfect.
Perfect.
Wonderful.
Yeah.
Thank you, Steve. Thank
Yep.
you, John, for being part of this conversation. This has been
Thank you.
it's been great conversation, and we'll get the video up tomorrow-ish. And we will be back next week for the last cybersecurity topic, when we'll be talking about BACnet. So see you all next week, and thank you again, John. Bye.
John.
Thanks very much.
Thanks, John.
Cheers.
Okay.